All right. Sorry, everyone. All right. Crypto, can you mute your mic? Can you mute your mic?
Yeah.
All right. Welcome to class. Today we're going to be learning about networking. Woo! This is a fun class.
Huh? Hey. Oh.
Will,
Well.
do you want to explain what networking is, and then I'll do all the chips?
Oh yeah, sure.
Or I have this
So one of the main
contraption.
benefits of CV2 versus CV1 is we have something called networking, which isn't unique to circuits. Like every like multiplayer bit of like computing uses networking. Basically, all it means is if you have something that's happening or information that exists on one client. When I say client, that means like a player. So like I'm on my own client, you're on your own client. If you have something happening on one client, networking is how you get it to go over to another client. So either you could have it be the same, like when I move to my left, you see me moving, that's networking. When I move back, you see me go back. Or one of the most powerful parts about circuits is you could optionally have it not be the same. So for instance, if we have like a text component on the wall and you want it to say something, like maybe you want to say the name of the local player. So that would obviously be like different text for every person who sees it. So that's how you do it with networking. Like in that particular case, you would unsynchronize it. A lot of things in Rec Room is synchronized by default. Like generally at this point in the class, everything you've used has just been set up in such a way that networking will kind of just happen intuitively. You don't have to worry about it. But once you figure out how it works at like a lower level, you can unlock a lot more abilities.
All right.
And so some of the main ways we're going to do that are with synchronized variables and events, are the main avenues of working with networking in Rec Room.
Yeah, your mic is rough. Did you guys get all that, or do I need to recap it? You got it. All right. So to start off with this little thing here. Something important to know about networking is that some things are like networked no matter what. You don't really have control over it. For example, one thing is the position of stuff in a room that is automatically networked from player to player. But importantly, it's not like all of us in this room are telling everyone else that like this beacon is placed there. The person or player saying where that beacon is the authority of that beacon. Only one person can be authority over an object. So let's say I'm authority of this beacon, right? If I move it, I'm telling all of you guys that this beacon is now here. And then on your local client, you're seeing that this beacon is now there. But what if someone else wanted to move it? Well, you can, but it's gonna take a little bit of network heat on like for with circuits. If you look at your maker pen, you'll see at the very top there's 4 bars. One is ink, one is CPU, one is net, and one is chips. We're gonna look at net. Network heat is pretty much how many signals you can send over to other players with like data, if that makes sense. Let's say you wanted to set the position of this beacon, but you weren't authority over it. Your network heat would go up just a little bit because you're sending a signal over to the authority of the object and saying, hey, move the beacon here. And then the authority will take care of it. you have very limited network heat. As you can see, it's out of 5. That number will actually get bigger with less players. So if you have a room that can have up to 40 people, your network heat will become lower, like your limit will get lower. If you have a room with like 10 people, that number would be higher. This room supports, I think 40 or maybe 20. Yeah, 40. So our network heat's pretty low. Anyways, a way to get around some things, especially for like the position of stuff. If you are authority over an object, you're gonna be telling people where it is, and that won't make the network heat go up. So here we have a little example. This is going to get the position of whoever clicked the button and then set the position of the beacon. It's super simple. But right now I'm authority over this beacon because I like touched it last. That's another way to set authority of something. If you grab an object or move it with your maker pen, or like a physical object touches your hand or something, you'll become authority over it. That's just how Rec Room will automatically change authority over an object. But here, if I click this, it'll move it to where I am. And my network heat is staying at 0 because I am authority over it, you know? But if someone else were to try to set the position of it by clicking the button, if you were looking at your maker pen, you would have seen your network heat go up. Keep in mind, network heat is different for everyone. You all have your local network heat. It goes up whenever you send a signal to someone else, not if someone else is sending a signal. It's not like a synced network heat limit or a network heat value. So while this isn't a problem when you just click a button once, because the network heat can be like relatively high, if you were to try to make that move smoothly, you'd run into a problem, and we'll show you the solution. If I put a event receiver and a update event and connect this, you'll see. Are you guys all getting network errors? Like if you pull out your maker pen, you're hearing an error message, right? I'm not, because I'm authority. Although what's happening right now is everybody in the room is trying to set the position of this. So everyone here is trying to set it, even if you're not authority over it. So then you will basically immediately run out of network heat. And the position of it's already synchronized. So ideally, we would just make it so only the authority of the object is the person like setting the position of it. So let's see how we can do that. I think there's a question. Okay. All right, so here are pretty much the 3 different sets of chips to filter stuff. Here we have authority. This is what I was just talking about with authority over an object. This is local player. So if you wanted to make stuff only happen for just one specific player, but then obviously you only want those chips to run for only that player, I'll give a use case for it. And then room authority. This player is usually the first person to join, but sometimes it'll recalculate who's room authority. You can manually recalculate room authority with this chip. And what it will do is it'll look at all the players in the room and it tries to find the best person to host the room on. So that means like ideally a PC player or a screen mode player with a low ping. That is the ideal platform. but it goes in order of, I'm pretty sure from lowest is like Android / standalone VR, then iPhone, yeah, then console, then PC VR, then like PlayStation 5, I think is its own. It's powerful enough.
PCVR and high-end consoles are they're like the highest rank, and then it's like mid-level consoles, and then like mobile and standalone headsets toward the bottom.
Isn't it?
My mic ain't
But then
better, by the
there's
way.
PC right above. No, your mic. It sounds like you're in a carnival.
Yeah, weird. I think it's a software issue. Yeah, those are the main classifications. Generally, you don't have to worry about it too much, though.
Yeah. Yeah, that would rank pretty low. And then if there's a room full of people on screen mode, like a high-end console or PC, it'll just pick whoever has the lowest ping, meaning like it'll yeah. Okay. Here are the chips for Room Authority. This goes off whenever the Room Authority changes. It's an event, and it'll say who the new Room Authority is. This mainly will go off if you were to recalculate it, or if the Room Authority left the room, it would have to pick a new one. So that's when that would go off. Get Room Authority, it'll just tell you who the Room Authority is. If you hover over that Room Authority, I think is probably me, because I know it's a dupe man. I don't know why, but it is dupe man. If local player is Room Authority, it's just like, can you mute your mic, Crypto?
Uh-oh.
And recalculate Room Authority. I just said what it did. Okay. We'll come back to local player in a second. But get these are all like object authority things. So we'll start with get authority. Get authority, if it is in world scope, like how it is right now, it's not an object board. It'll just tell you who the room authority is. But if I had the beacon, for example, if I put this chip into the beacon circuit board, it'll output the authority of that beacon. Then if local player is authority, is same idea. It's just an if chip, and it'll output true if whoever is authority is the person who ran it. Player get is authority of. This lets you put a player and an object, and if that player is authority over that object, it'll output true. If not, it's false. Rec Room object get authority. You give it an object, and it tells you who's authority of it. And Rec Room object get is local player authority. Kind of a mouthful, although it tells you if the local player, so like for me, it's me, for you, it's you, is authority. This is one you'll probably use a lot. And then Rec Room object set authority. This lets you manually pick who's authority over something without them having to touch it or grab the object or something. Do all these make sense?
Yep.
Okay. Next up, we have the local player chips. Now, a lot of these are for like filtering stuff to ensure it's only happening, like something's only happening for the local player or everyone else. Get local player obviously is you. This is useful if you want to get the position of yourself or something. Local player, player get is local. I feel like that kind of explains what it does, but you give it a player, it'll be true if it's you, and it'll be false if it isn't. If player is local, this has a good use case for like this and pretty much the rest of these. Imagine you have like a player variable, like a synchronized variable, and then it like you wanted stuff fully to happen for whoever is in that variable, you know? So if I were to place a player variable, I'll call it like uh, I'll call it. Should do like a scenario here. Let's say we're doing it for like a hide and seek game, and we'll call it Seeker. So then this is the selected Seeker. Right? And note this is a synchronized variable, meaning whatever value's in it is the same for all of us. If I were to set the Seeker to me, you guys will hover over it, you'll see it's me. And then I connect this to like if player is valid and local. This is especially useful if you're using a variable because before you set anything in it, the player is going to be invalid. So this will like kind of prevent any errors. So then, Cheeto, can you mute your mic?
Oh, my bad.
So here, if this was like on game start, you could then have it so the seeker spawns in one place, and then if they're not the seeker, like if the local player isn't the seeker, they spawn somewhere else. And then if local player should run is, I think I explained this once, but if you run it, if this player is valid and local, it'll do this. If it is invalid, it'll check if the player who ran it is authority. If they are, then it runs it. So here's some use cases for this, and you've probably seen it in a button, right? I'll bring this button back over here. I think I said this once, but the event for button pushed goes off for everyone who noticed I clicked it. If you're really far away, it like there's a possibility of it not running because it like updates less. That doesn't matter, but for this case, when I click this is going off for everyone. But then inside of this object board is a if local player should run, which is then making it so only the player who clicked the button is then running the circuits after. So I'm gonna delete it from inside of this board. I'm gonna just directly connect the event to the is pressed and is released. So now that is gone and there's just an event going straight out. You can now see when I click this, those circuits light up for everyone. But now we have a separate issue of when I click this event's going off for everyone. And so all of you guys are trying to set the position of this and your network keeps going up. So what we can do is get a rec room object, get is local player authority, and I'll just kind of put that there. Grab an if chip. And oh, actually, I have to connect it to the beacon and the button. So now when I click this is going off for everyone. But then after this if chip, you guys will notice it's not lighting up for you because you're not authority over it. I am. So I'm setting the position of it. But now if we put this onto the update event, you'll now see this is following me, but no one's network heat is spiking way up anymore because only I'm setting the position of it because I'm authority. If someone else were to like click the beacon with their maker pen, they would then be the one saying the position. Right now it's on crypto, but I'm still authority over it because it's just getting who clicked the button last. That's how it's picking. But we could do like get we'll local player. And so now this will just go to the position of whoever is authority over it. If that's confusing for why this is working, what it's doing is on this 30 hertz, it is filtering out to only be authority. And then once it gets to authority, it's just checking if that local player, which in turn would be the authority here, and then it gets their position and sets it. So in this case, if we wanted it to move to someone else, we could add a set authority and then set the authority of this. I'm adding the local player should run back into the button because we really want this to run for one player. And so now if someone else were to click that, you'll see it's on me right now. It's default clicked it, so now he's authority and it's following him. If someone else were to click it, it would follow them. That's a simple way to save heat because it uses no heat. But there's some things that you can't control if it uses heat. For example, if I wanted to set the color of that beacon or set the height of it or something, I'm not already constantly telling everyone what the color of it is. I only tell you if it changed. So if you wanted to set the color of it with circuits or something, your network heat would go up a little bit. But I would hope that you're not like setting it like constantly. But let's say you did, you know, what we can do is make it local, meaning that all of us will locally set the color of the beacon opposed to just one player and then that one player sending out signals, because then it'd be less smooth. You'd have a limit and you'll run out of network heat. So what I'm going to do is I'm going to configure this beacon and I am turning off the synced check box on there. So this beacon is now unsynced. It looks the same for all of us. Nothing changed on it. It's still just a white beacon. But if we were to make a little just color changer, I'll do this. And I'm going to set this before I check for authority because I want everyone to be doing this. I can't connect it yet though. So I'll just take this chip. I'll get the lifetime. And here's another hack for synchronizing stuff. This gets the instance lifetime, obviously, which doesn't sound that useful unless you're making like a mod gun or something and you want to know how long the instance has been up. But it is actually super useful because this is a number that is synced for all of us. This number is the exact same for everyone without taking any network heat, which is super nice. And it's down to like 3 decimal places or maybe more. Like, how precise is it, Will?
It's 3.
Yeah, he made it. So he'll never say that. So I will add a divide. We're just gonna do very simple math to like slow it down. And then I'm grabbing a modulo because hue saturation value can only go up to 1, so we have to go back down to 0 after. So Modulo will do that for us, and I'll divide it by just like 2. This is going to determine the speed. And so now, if you hover over this, the color is constantly changing. So if I connect this, and I connect it to the beacon, and the update, you'll now see this beacon is rainbow. And it's just changing colors really fast. But importantly, the color is the same for all of us because it's doing the exact same calculation with the exact same numbers. This number on the instance lifetime is the same. So if you divide it and modulo it by 1, the number will end up being the same. In turn, this beacon is the same color, even though it doesn't really matter for rainbow. And then check if they're authority and set the position. Now there's a rainbow beacon that can follow someone. And if someone else clicks it, it'll follow them but will remain rainbow. Importantly, if I didn't, what are you doing? If I didn't unsync was still synchronized, you'll see the network heat is spiked up and we're getting errors. Even though I'm authority over it, I'm still getting errors because regardless of authority for setting color or height and stuff like that, it'll make the network heat go up a little bit. So yeah, any questions? Potential Wolf.
Can you use time get precise seconds instead of instance as well?
All right, so time get precise seconds is an older chip than this. The number on it is not the same for everyone. That number is how many seconds it's been since you like opened Rec Room. So obviously that number won't be the same for everyone.
Oh, I see what you mean.
That's why Will made this chip in the first place. So there would be a synchronized thing. Yeah. Any other questions? Nope.
One more thing.
All right. Oh, okay.
Does it matter? Well, like if you divide it more, does that like slow down?
Yeah, in this case, it would. I think right now with this math, it would take 2 seconds to make a full cycle, like on the full hue saturation thing. If it was 1, it would take 1 second to do it. But like if I made it 5, it'll take 5 seconds to get all the way through it.
Oh, okay, gotcha.
Yeah.
All right.
All right.
Thank you.
Yeah. Will, do you want to add something on to it?
No, I think that's it. Have we gone over how to configure event senders?
No.
Okay.
Oh, well, like
explain how that works.
Briefly in the last class.
Okay, we can do a little bit better example, I guess. So let's take out. So this is an event sender. You used these yesterday in our event lesson. If you configure it, however, there is a drop down. So you can feel free to spawn one in front of you and configure it, and you'll see a drop down. And when you click on that, there's a few options. It starts off by local. Starts out as local by default. This is who it's sending to when you run the thing. The first option is all. That means when you run it, like you can only run the chip on one player. Like only one player will be running it. Maybe others will be running at the same time, but that's kind of an independent action. When you run it, if you set it to all, the event receivers will then run for everybody in the room. It won't just be you like we had yesterday. It'll send out to everyone else in the room. There's authority. Authority will just be whoever is the authority over the current context. If it's at the global scope, that means it'll run for room authority. If it's in some object board, for instance, it will run for the authority of that object. The other options are local. That's the default, just yourself. Others, this is everybody except for you. There on the bottom, there's a room authority. That's just the authority over the room. And there is one other option here, player. If I set it to player, you'll see it'll actually add a target player port. This allows you to like wire up an actual player reference into that port. And then when you run it, it'll only go to that specific player. It's pretty useful. Alternatively, like if we didn't have this, you'd have to send it to like all and then attach a player as part of the data and check on the receiving end. I should probably explain a bit about how authority and room authority work. I know Snug talked a little bit about this, but just to elaborate, every object in Rec Room is controlled by some sort of authority player. Rec Room instances, at least currently, do not have dedicated servers. This is a peer-to-peer game, which means one player in the room is the room authority. They're basically hosting the server that we're all playing on in terms of gameplay. And then, like as Doug mentioned, they're usually the first person to join the room. If they leave, it will run some calculation to determine the next authority. What room authority is, though, basically is it's like a default for object authority, because objects also have their own authority. So if I have like a basketball prop that I spawn in the room, and if I spawn it, I pick it up, I'll be authority over the ball. If I throw it to you and you pick it up, you are now authority. It will have transferred over to you because you were the last person to physically interact with it. And the reason it does that is because it's like things are just a bit smoother for authority over the object. Like if you were authority over a basketball and you threw it, when I see it, it wouldn't be quite as smooth. It would be kind of like a little bit laggy because you're sending it out over the network. It's not like physically simulated on my end. Yeah, so that's part of the reason, like it doesn't take up network heat if you do it on something you're already authority over, because then you're you're already sending that all over the network. So like it's not actually generating any extra heat. Do you have a question, Crypto? No? Okay, cool. Cool. Any other questions? Is that it, Snug?
You want to do an example?
Yeah, so let me put together an example when we did last class. Something you might see. Let me turn off push to talk. One sec. Okay, so something we did last class, like last semester, like a good example for networking is if, for instance, you have like a lot of lights in a room and you want to turn them all on or off at the same time. You might not, like it might not work if you just have them all synced and you have one player just run lights on for every light in the room, because you only have like 5 RPCs at a 40 player room before you hit the network heat limit. So one good alternative is to unsynchronize them. Like when you configure it, as Snug showed you with the beacon, lights will also have this toggle. It's just a sync toggle, which means it will change from any player who makes a change to it will automatically be synced to that no longer happens. Like every player is responsible for making their own changes. So let me take out a few lights. Okay, cool. So here's just my point light. Let me get it in place. And we want to have an event to turn on or off. So let's take out a event definition. And I'll just name this something like light toggle or light set. And on that event definition, I will add a property called on, and this will be a bool. That's just the default. Let's add that. So let's take out this event receiver, and I'll put it up here. Let me configure that to light on or light set. There we go. And you'll see it has that on property, as we talked about yesterday from the event definition. And you'll see that the light has 2 separate input ports, turn on, turn off. Most components actually have this just in one exec these days, but light's kind of older. So let's run this through an if. We have the on, so we can just split it up as we need to go either into on or off. Okay, so if light on is true, we'll run this into turn on. If it's false, we'll run it into turn off. So let's take out an event receiver. Or sorry, event sender. And let's configure this to our light set event. And that's false. Let me run this. And you'll see the light has turned off. You'll notice I haven't done anything at all that involves networking yet. Are you shaking your head, Snug?
Light's still on.
Are you sure?
Yep. Oh, we have another light on it. I should move it so it's easier to tell.
Yeah. I'll make it like red so it's a little visible. Cool. Yeah, okay, so you'll notice the light went off. You'll also notice I haven't done any networking at all. Like that was just the default behavior for the things I put down. But one side effect of that is that if I now flip this to on and I run it again, you can't see it, of course, but if I look at my network heat, there's a small amount of network heat that gets used up when I do that operation. And that's because when I run this, so as we talked about before, this event center will default to local. So when I run it, I'm the only one who runs this event receiver here. So why is the light turning on for you? It's because when it gets here, I run the chip to turn the light off. That's still just running for me, but the light is synchronized by default. Like if I configure it, there's a little bool toggle on it, which will make it so if any changes that any player makes will propagate to everyone else. So when I turn it off, that gets automatically synced by Rec Room over to you, and you see the light off as well. Now, that's all fine, but if I take this light and if I clone it a bunch, let me just take these chips, make a few of them. So this is 4. This is probably still fine, but if I run it on or off, that will still take a little bit more network heat. And if I have a room that maybe has like 40 lights in it or so, you'd very quickly run out of network heat. So let's instead make them all unsynchronized. I'm going to configure it, and there's a sync toggle. I'm going to hit that toggle to make it unsynced on all 4 of them. So now they're all unsynchronized and they are all on. So let me run this to turn it off. When I do that, they all turned off for me, but they won't have turned off for you because they're now unsynced. So any changes I make are no longer being automatically sent over to you. What I can do instead, however, is if I configure this event sender definition, event sender, and I change it from local, I'm going to configure it, and in the target dropdown, I'll change it from local to all. Then this way, when I run this, now this has gone from being local to networked, from local to all, which means it was previously not at all networked, but now it is networked. So that will create more network heat than it was before. So like it is doing networking, but instead of having to do the networking on every single light, you're just doing it once here. So you could have like 2 lights or 100 lights, but your network heat would be the same because it's just the one little event sender here. So let's turn this off, and you'll probably have seen that they all just went off when I run this. They're all going on, and that is at a fixed cost to the network heat. Like as many lights as they have, it's not going to grow even more. So if you're doing something like that, it's important to try to like minimize the number of RPCs. When I say RPCs, by the way, you'll see that up in your network heat at the top of your MakerPen tab. That's currently there's 5, so it says 0 out of 5 right now. That just means anytime you like run an operation which carries data over to other people, that's 1 RPC, and these are averaged over a few frames. So try to keep them pretty low. Cool. You could do something similar, setting the color like Snug had earlier with the beacon. Yeah, there's lots of applications for that. Cool. Any questions about that, or can we go on to work on our assignments?
Can you do it with a for each?
Oh, you mean like not using event receivers?
Okay.
Yeah, that's a good idea. So let me configure all of these. I'll have a special tag. I'll just give them light test. And let me delete everything else. So what Snug was saying is instead of using event senders, there is even a more optimized way to do this. Like I can literally configure this. Yeah, I can remove the board. So you literally don't need any chips on the receiving end. So let me clone this a few times. Got all these lights, still unsynced. So let me take out a 4 each chip. And I think we've used this briefly before, but this will just iterate over. That's weird. This will just iterate over a list of objects, running once for every item in the list. So the other main chip I'm going to need is get all with tag, rec room object get all with tag. So let's hook that up to the list input. And let me type in here, light test. And when I do that and I hover over the output, I can see there's 5 items. So it's finding the 5 lights I have over there with the light test tag. And then when I run over this list, first of all, this is going to return a list of rec room object. Rec room object is, you can think of it as the base type for all components. So if I take out a light turn on chip, and light turn off as well, you see that these have a target input. This is not a rec room object. This is a light. A rec room object is not necessarily a light, but a light is necessarily a rec room object. In this case, so like that's why we're not able to wire it. If I try to make this wire, it won't work. But in this case, we know that because they're coming from the list of items with this tag, we know that they're going to be lights. So we can use a from rec room object chip, hook that up to the item port here, and that will convert it from rec room object to light. It knows what to convert it to based on what you connect it to. So it knows it's going to a light. And we're going to have a, let's try a toggle button since that will just maintain the state for us.
You should check if it's true before the for each and have 2 for eaches.
Oh, yeah, that works. So what Snug just suggested is a little heat optimization. So you don't have to, instead of checking whether you're going to turn them on or off for every single light, we're only going to check it once, and that will save you from having to run that if chip every time. Let me just wire some of this stuff up. We can use the same list that just wires into both. I'll take out an if chip to split on whether or not it's on. Okay, we can hook this up to is pressed on the toggle button. That will just tell us directly whether or not the button is pressed. And then, actually, like we don't even need that since this already has pressed and released. So let's just wire that up directly from pressed. If it's pressed, we want it to be on. So let's hook it up to the on pressed loop. When we release it, we'll hook it up to the toggle off loop. And then we'll connect this to the target. Cool. So this is only running for me because there is a chip inside of this, which will make it so it only runs for me. As the person who presses it, let me just wire this around those chips so those chips get ignored, and it'll run for everybody. And now you should see it turning on or off using, I think this actually takes 0 networking because it's running as you press the button, and interacting with objects outside of circuits doesn't take network heat. Cool. Any questions about that? Do you have one, Orbital? Okay, cool. We ready for the assignment?
Yep.
Cool. Okay, so what we did last semester, which was pretty decent example, I think, is to make something where you press a button and it prompts you with the text input. There's a chip prompt local player or prompt player text, and it gives you a text field. Type in where you can type in the name of a user in the room, and it will convert that string, like the string of the username into the actual player reference using the get player by account name chip or display name, whichever you prefer. And then it will show them a subtitle saying hello, their username from whoever the player who sent it with the text prompt is. You're going to want to use an event sender configured to the player type, which I was showing you earlier. Just configure it, set the target type to player, and then wire in the player that you got from their username into that port, and then use a show subtitle chip once they get it. Cool. If you have any questions, come over to any of us. Okay. Yeah, everyone can head off and start working.
Have fun. Woohoo.
Fun my butt.
Hey, Snug.
Wait, hold on. What was it?